Good evening. Hi everyone. In my previous videos, I was blessed to give information concerning with air standard cycles followed by internal combustion engines. In addition to that, I could deliver a lecture video for about 15 minutes specifically on gas turbines. But in this lecture video, I'll be very happy to strewn information pertaining to the continuation of gas turbines. That is the first one, methods to improve the cycle thermal efficiency, followed by jet propulsion cycles. In single video, I would have comprehensively covered information pertaining to gas turbines and jet propulsion cycles, but let it be fragmented. If I give the information in installment, anybody will be in a position to follow that. Friends, in my previous video, I could give information concerning with the definition of a gas turbine, generally speaking the classification of turbines, next classification of gas turbines, mainly focusing on closed cycle and open cycle gas turbine plant. Next, advantages and disadvantages of gas turbines. Later, I could cover the analysis of gas turbines depending on ideal and actual breakdown cycles. So this is what the pressure, volume and temperature entropy plots I could consider for explaining the thermal analysis of gas turbines. You all know that in the air standard cycles we could learn thermal analysis of 5 cycles, namely Carnot, Otto, Diesel, Dual and Stirling cycles. This I have even covered in my other lecture sessions. But now, after knowing the entry level information in gas turbines, you should know the methods required to enhance cycle thermal efficiency of gas turbines. You may be wondering where is the need for increasing the thermal efficiency of gas turbine. You all know from the primary information, gas turbines have very poor thermal efficiency. But mechanical efficiency will be of the order 95 to 98%. Extraordinarily good. Also, the speed of the gas turbine, the rotational speed will be tremendous. 35,000 rpm to 40,000 rpm. Unassailable value. But it has many limitations, demerits. That is why very oftenly it cannot be used for power generation. Keeping this information in mind, we should know how or what are all the methods required to enhance cycle thermal efficiency. Just peeping to the pressure volume plot, we can get the information that generally speaking in a gas turbine unit we have one compressor, combustion chamber, gas turbine and cooler. But when we take up the methods to improve cycle thermal efficiency, we have very prominently 3 methods. One is the intercooler based gas turbine, second one is the reheater based gas turbine, then the third one, very important, regenerative based gas turbine. For this, it is very much essential to write the flow diagram followed by temperature entropy plot. For that, this is the yardstick. If we are not well acquainted with this TS plot, you will not get to know any information concerning with intercooler, reheater and regenerator. Let me give the information in a very synoptic or epigrammatic way so that any layman will be in a position to understand. When you take a intercooler based gas turbine, referring to this TS plot, we can take a usually an intercooler is incorporated between low pressure and high pressure compressors. So, please bear in mind, kindly note that an intercooler is incorporated between low and high pressure cylinders that have the potential to achieve the process of compression very judiciously. Next, one combustion chamber, gas turbine, cooler, those components remain the same. But in an intercooler based gas turbine, we will be using two compressors. In one of my lecture videos, exclusively I have focused on the information pertaining to methods to improve cycle thermal efficiency. Since this video concerns with a synoptic overview, I will not be giving the information very detailed. In a concise manner, if we can understand, then we can take up the information elaborately. Kindly bear in mind, so to achieve the process of intercooling, we consider two compressors. Likewise, when you take a preheater based gas turbine, that is exactly the opposite of intercooler. Reheater is incorporated between high and low pressure turbines. When we take up compressor, it shall be from low to higher value of pressure. But when we take up turbine, it is exactly the opposite. The process of throttling will take place. Higher magnitude of pressure shall be converted into lower magnitude of pressure. When we come to jet propulsion cycles, we can know the information in depth. So, reheater is unquestionably incorporated between high and low pressure turbines. Lastly, we have regenerative gas turbine plant. What generally is regenerator? I think when I was delivering my session in one of the lecture videos, particularly focusing on Stirling cycle, Stirling air standard cycle is a regenerative gas power cycle. Why we call that as a regenerative gas power cycle? Why? Because in a Stirling engine, regenerator was incorporated. Regenerative process, repetitive generation of heat takes place. That is why unquestionably, indubitably, it is referred to as regenerative gas turbine plant. The same idea we could follow even in gas power cycle. In case of Stirling cycle, regenerative cycle, but here gas turbine, regenerator, heat exchanger is used. Professionally, it is a regenerator. In a colloquial context, even a layman will be in a position to understand it is an heat exchanger. Very close to the combustion chamber, and heat exchanger is juxtaposed. So please bear in mind, the thermal efficiency of a gas turbine is very poor, 15 to 18%. So marginally it is possible for us to increase cycle thermal efficiency, maybe of the order 20 to 25%. Even there is a practical possibility that all three can be incorporated in a single gas turbine unit: intercooler, reheater and regenerator. So just now I said in one of the lecture videos delivered by me, exclusively a session on methods to improve cycle thermal efficiency has been comprehensively covered. This is the second segment in gas turbines. In my previous video, I could exclusively concentrate on the rudiments of gas turbines. In this video, I am focusing on methods to improve cycle thermal efficiency. One more small topic adhere to gas turbines, let me be very pleased to cover, that is jet propulsion. Usually in the undergraduation level, as said in many of the lecture videos, applied thermodynamics shall be studied by the students, irrespective of any institution or any prestigious university. Engineering thermodynamics follow the same curriculum. So friends, along with gas turbines, a small theoretical module, jet propulsion systems, has to be studied. In the post-graduation level, or if a student pursues MS program exclusively in thermal engineering, he or she will study about jet and rocket propulsion. That was one of the elective courses even in UG programs, but currently most of the universities are not floating that since it is very esoteric and enigmatic to understand. So, in undergraduation level to learn jet propulsion systems, students and teachers are supposed to learn and teach jet propulsion systems in a theoretical manner. What theory we need to learn? Let me tell you, in jet propulsion we predominantly take up two: air breathing propulsion systems, next intermittent combustion propulsion systems. The term propulsion sounds to be very unique. Propulsion. So that is very professionally articulated. It has wonderful technological soundness and relevance. But even though the term propulsion can be interpreted in a broader context, in thermodynamics we shall know the essence of it. Just now I said air breathing propulsion systems. In that, in the undergraduation program we study turbojet, turbofan, turbopropeller. The three types of air breathing propulsion systems used in aircraft systems. You know that the rotational speed of a gas turbine is tremendous, ranging from 35,000 to 40,000 revolutions per minute. This is impossible in the case of internal combustion engines. That is why gas turbines shall be preferred. When we take up turbojet, turbopropeller, turbofan, the conventional components remain the same: compressor, combustion chamber, gas turbine and cooler. But in addition to that, we find diffuser and nozzle. Diffuser very closely incorporated to a compressor, but nozzle very closely juxtaposed near gas turbine. In compressor, we expect higher magnitude of pressure, but in the case of nozzle, we expect higher magnitude of velocity. Tremendous velocity shall be accomplished. The same shall be elaborately studied in yet another module called steam nozzles. Compressors and steam nozzle, yet another interconnected model or module what you need to learn in engineering thermodynamics. Lastly, we have a concept called ramjet. In ramjet, ram meaning tremendous velocity, we use supersonic and subsonic diffusers. When we hear to the terms supersonic and subsonic, naturally a dimensionless number flashes to our mind, which is that Mach number, named after Ernst Mach. We have learned the significance or the physical importance of Mach number while learning in fluid mechanics, fundamentals of fluid mechanics. So here an application aspect comes. Lastly, rocket propulsion along with jet propulsion. Learning turbojet, turbofan and turbopropeller, we learn rocket propulsion. As said 5 minutes ago, jet and rocket propulsion is a very comprehensive course. For one full semester, we can learn jet and rocket propulsion. That is absolutely difficult topic. If you wish to take up an illustrative problem, minimum of about 4 to 5 sheets you require. It requires too much patience and the mathematics. You need to have extremely good mathematical background. So mathematics is the lingua franca for learning any analytical course. Lingua franca is not an Italian word, it is a linking language. Okay, normally in the English proficiency we use lingua franca. Even in analytical subjects, by learning technical education, we can use the term lingua franca. For any analytical course, which is the lingua franca? Mathematics. So you should have extraordinary mathematical background in learning jet and rocket propulsion. But in the undergraduate level, you will learn to the theory of rockets. A simple schematic of a rocket, what are all the components festooned in a rocket we need to learn. So this is what the essence of jet propulsion systems. So in a nutshell, when we wish to learn gas turbines followed by jet propulsion, we have three segments. The first segment is the pure background, the basic. The principle of operation of a gas turbine, the components in a gas turbine unit. Then we need to know the differences between closed and open cycle gas turbine plant. Next, we should be aware of advantages and disadvantages clearly. Then we will come to the analysis of ideal and Brayton cycles. Throughout problem solving, we deal with pressure ratio. Pressure ratio is the yardstick. I have emphasized in many other videos, when you learn the gas turbines very elaborately, you can fathom the other topics like compressors, vapor power cycles, refrigeration, and even nozzles. So all modules in the applications of thermodynamics are interconnected. Then we could learn the methods to improve the cycle thermal efficiency of gas turbine. Eventually, the theoretical aspect of jet propulsion. So this is what the exhaustive content, what you need to remember in learning gas turbines and jet propulsion. That is all I wish to convey in this video. All the very best. Do well. Thank you.